All right, this is worksheet 1.3. We're not necessarily doing a quiz on it, but just to kind of give you an idea how to do these without a calculator. On the first one, you should always, with a limit, plug it in and see what happens, right? If I put -2 in there, -2 to the third power is -8. -8 minus 2 is -10. And -2 minus 3 is -5. We end up with 2. If you get an answer, that's your answer, right? You don't have to do anything else or worry about. Same thing here. If I put 3 in, I'm going to get 3 squared 9 times 2 is 18 minus 15 plus 7. So I end up with 10 on the top. And on the bottom, I get the cube root of 8, which is 2. 10 divided by 2 is 5. All right, so neither one of those required anything fancy. Just plug it in and evaluate. Now, when you get to here, if I plug -6 in, I will get 0 over 0. And so that's a concern, right? It's what we call that indeterminate form. Don't know what that equals. I got to do a little bit of extra stuff. Next chapter will show you a real easy way to do this. But for right now, the only possible way for us to go about doing this is to factor. And so I factor that into y plus 6, y plus 3. I let the y plus 6's cancel. And now I have this y plus 3. And what we're saying is that while this function is not exactly y plus 3, it sure does look like it everywhere on its graph. So if I put -6 into this, -6 plus 3 will give me -3. That's what the graph will look like. It's not necessarily equal to that, but it sure will look like that if you were to graph that out. All right, so without a calculator, we can still kind of process some of that. Same thing here. If I put 9 in, I'm going to get 0 over 0, which tells us nothing. Got to do a little bit of work. Now this one requires kind of a funky thing. We're going to multiply the top and bottom by what we call a conjugate. So I just take that radical that's up here, this kind of goofy looking thing, and instead of minus, I'm going to use a plus. All right. When I do that, I'm going to have square root times square root, which will give me what's underneath of it. The outside and the inside will cancel. We did that on purpose. That's why we used the opposite there. And -2 times 2 is a -4. Okay. Down below, I don't want to do anything. Don't start getting silly and try to work this out and FOIL it out. You'll be sad you did, because what happens on top is I get x minus 5 minus 4, which is x minus 9, and that cancels here. And so now we have this. All right. And what, again, we're saying is that this isn't the exact same thing as this, but it looks exactly the same on a graph. There might be a hole in the graph or a dot, something that's missing, but otherwise it's exactly the same. So when I put 9 in here, I'm going to get square root of 4, 2. 2 plus 2 is 4. We're going to end up with 1/4. This function looks like it equals 1/4 at 9, even though it doesn't technically equal that. But that's the idea of the limit. What does it look like it equals, right? So I come here and I throw the 1 and I get 0 over 0. So right away I'm kind of thinking I need to do something. And you could do a lot of work that maybe you don't even need to. Like if you look at the bottom, you can pull a 10 out and you'll have x squared minus 1. Well, x squared minus 1, x squared minus 1 actually cancels, and we're left with 1/10. So if you were to graph this originally, it would actually be just a line at 0.1 with a little hole in it at 1. And so therefore, what does the function look like it equals? It looks like it equals 1/10. All right. And then our last one here, if I put 0 in, I'm going to get 0 over 0. Again, that's an issue. So down below, I can see that I can pull an m out. It'll leave me with m minus 3 left over. That m can cancel with this m. And so now I've got 3 over m minus 3. And again, we're not saying that that's the same, but it sure does look the same as that. And so now if I put 0 in here, I'm going to get 3 over -3, which is -1. That's what that function looks like. All right. So a little bit of work without a calculator. Again, 3, 4, 5, 6, we're going to show you something called L'Hopital's rule next chapter that will give you these exact same answers, maybe in a way that you find a little bit easier. But this is how we have to do it today.